We are starting now mechanics paper for the year 2023 for May June. It's paper 4 of mechanics 9709/41 is the code. May June 2023 1 hour 15 minutes is the total timing for this paper and 50 marks of this paper there. Now we are going to start one by one question of this. Two particles P and Q of masses m kg and 0.3 kg respectively are at rest on a smooth horizontal plane. P is projected at a speed of 5 meters per second directly towards Q. After P and Q collides, P moves with a speed of 2 meters per second in the same direction as it was originally moving. Find in terms of m the speed of the particle Q after this collision. And B part, another after this collision, Q moves directly towards a third particle R of mass 0.6 kg, which is at rest on the plane. Q is brought to rest with the collision with R, and R begins to move with a speed of 1.5 meters per second. Find the value of m. Since the particle P and Q, they are at rest, this is particle P, this is particle Q, this mass is m kg, and the mass of particle Q is there 0.3 kg. It is moving with a speed of 5 meters per second, whereas this particle is at rest. And after this collision, P particle is going to move with a speed of 2 meters per second, and the speed of the particle Q there is v, which is going to be calculated in terms of m there. Now we can use the concept of linear conservation of momentum for these two particles. Momentum before collision is equal to momentum after collision. So this particle will be m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Since m1 is m there, u1 is 5 plus m2 is 0.3 and it is at rest. m1 is m there, velocity of that particle is 2 and m2 is 0.3 and v2 is v there, because the speed of the second particle q is unknown in that terms there. So this will become 5m plus 0 is equal to 2m plus 0.3v. So this will calculate it as 5m minus 2m is 3m is equal to 0.3v. So v will be equal to 3 over 0.3m, and that thing is equal to 10 m is the speed of this particle v there in terms of m, which is equal to 10 m there. For this second particle, it is on the same line of the horizontal, and q is now going to strike with this particle r there. Whereas m1 is equal to m is equal to 10 m, and r2 is having the mass equal to 0.6 kg. Then this u1 is the speed of this particle q there, which is equal to is 0.3. u1 is the speed of this particle before that one is 10 m, and this particle is at rest there. After this collision, q with r, q is going to be at rest there, and particle r is going to move with the speed of 1.5 meters per second. Now again, using the law of conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, where m1 is 0.3 into u1 is the speed of that particle of this q before the collision is 10 m, plus m2 is 0.6, but it is going to be at rest at that position. So u2 is equal to 0 there, equal to m1, that is equal to 0.3, and it is going to be at rest after this collision. And m2 is going to be 0.6 into the speed of that particle is 1.5. So this 0.3 into 10 m will become 3 m plus 0 is equal to 0 plus this 0.9. So m is equal to 0.9 over 3. That thing is equal to 0.3. So the mass of this particle m in terms of that is 0.3 kg, which is going to be calculated of this particle in terms of the m there. Question 2 now. A particle P is of mass 0.4 kg is projected vertically upward from the horizontal ground with a speed of 10 meters per second. Find the greatest height above the ground reached by the particle P, and when the particle P reaches the ground again, it rebounces vertically upward. At this instant that it hits the ground, P loses 7.2 joules energy. Find the time taken between these two LSs, between first and the second particle instant at the which P hits the ground. Now, Let's say it is the point O from which it is being projected upward with a speed of 10 meters per second, and it reaches at the highest point A there. We know one thing, that at point A, its final velocity would be equal to 0 because it is moving upward. So acceleration is equal to minus g, and that is minus 10 meter per second square. Now we are going to find out this height h there. We have this equation v square minus u square is equal to 2gs. So v is there 0 minus u is there 10 square. That thing is equal to 2, g is minus 10 into s is the height h gained by that particle there. So h is equal to minus 100 over minus 20, and that thing is equal to 5 meter. So it is going to gain a height of 5 meter from the ground there. For this second particle, B part, it was the first bounce of that. Then it moves for the second bounce, and from this first to second position, the total time taken between these two is going to be calculated for this part there. But they have lost the energy equal to 7.2 joules. We know one thing, that at this point B to this point C, let's say this is the height again there, and that is small h. We know that it has total kinetic energy at the start of that one is equal to half mv square. That is half m there is 0.4 and v there is 10 square, and that thing is equal to 20 joules. But it has lost after this first impact with the ground 7.2 joules. So we can have to calculate the speed at this particle. Let's say that is u after this second impact when it is going to collide with the ground there. So half mu square is equal to total energy lost there is, at this point it was 20 minus 7.2 joules it has lost for that part there. No, half mass of that particle is 0.4 into u square, that is equal to so u square is equal to 12.8 over 0.2. So u square is equal to 64, or u is equal to 8 meters per second. So at this point B, when it bounces back to that part, its u is equal to 8 meters per second. Since at the highest point its velocity is equal to 0 and g is equal to minus 10 meters per second square. So we can use this equation, v is equal to u plus gt. Final velocity is 0 there. U is there 8 minus 10 into t. So time t is there 0.8 seconds. But from this point B to C, this is if time t, then this is also time t there. because you have to take the total time taken from the first to the second of that impact there. So it is 0.8 second, it is moving upward. So total time is equal to zero point 0.8 plus 0.8, that is equal to 1.6 seconds is the total time taken by that particle for the second bounce of that. A particle moves in a straight line starting from rest. The displacement s meter of the particle from a fixed point O on the line at t second is given by s is equal to t power 5 over 2 minus 14 over 4, 15 over 4, t power 3 by 2 plus 6. Find the value of s when the particle is again at rest. So we know from this calculation that when the particle is going to be again at rest, that means what? Velocity of that particle is equal to 0. So you are going to calculate the velocity of that particle where v is equal to ds over dt, and that thing is equal to 0. Now ds over dt is equal to 5 by 2 t power 3 by 2 minus 15 over 4 into 3 by 2 into t power half plus 6 derivative is equal to 0. So that thing is going to be equal to 5 over 2 t power 3 by 2 minus 45 over 8 t power half. Now this thing is equal to 0 because velocity is equal to 0. You are going to get the time for that part. So this thing will be equal to 5 over 2t power half is common. It should be t minus 9 over 4 is equal to 0. So either this portion is equal to 0. This implies that t value is equal to 0, or t minus 9 over 4 is equal to 0, or this implies that t value is equal to 9 by 4. Now you put time 9 by 4 seconds in the displacement equation, then s will be equal to 9 by 4 power 5 over 2 minus 15 over 4 t power is 5 over 9 over 4 to the power 3 by 2 plus 6. That thing is equal to 3 by 2 whole square power 5 by 2 minus 15 over 4 3 over 2 power whole square power 3 by 2 plus 6. This 2 and 2 cancel. This 2 and 2 cancel. So it should be left there 3 by 2 power 5 minus 15 over 4 into 3 by 2 power 3 plus 6. And that calculation, after doing this one, it is equal to 0.97 So this is the displacement equation of that question number 3, which is starting from this point O and moving on a straight line. The equation as s is equal to t power 5 by 2 minus 15 over 4 t power 3 by 2 plus 6. The velocity of a particle at t seconds after leaving a fixed point O is given v meters per second. The diagram shows a velocity time graph which models the motion of the particle. The graph consists of 5 straight lines segments. The particle accelerates to a speed of 0.9 meters per second in the first 3 seconds, then travels at a constant speed for the 6 seconds, and then it comes to rest at 1 second later. The particle then moves back and returns to the rest at O at t seconds. Find the distance traveled by the particle in the first 10 seconds of its motion. B part. Given that t is equal to 12, find the minimum velocity of the particle. And C part. Given instead the greatest speed of the particle is 3 meters per second, find the value of t, hence find the average speed of the particle of this whole journey of that motion there. The total distance traveled in the 10th second of this part there, because this graph is consisting of a trapezium shape. Let's say it is O, it is A, it is B, it is C there. So total distance traveled is the area of trapezium, which is equal to half into the height into the sum of parallel sides, that is AB plus OC. And height is basically this H there. So this is basically equal to half. The distance between this parallel side is 0.9, because this is the height of that object, into the sum of parallel sides. So this side is AB is basically equal to 9 minus 3, 6, and OC is basically equal to 10. So that thing is equal to half into 0.9 into 16. And that thing is equal to 7.2 meters is the total distance traveled in the first 10 seconds of that motion of straight lines. Now part B. Given that t is equal to 12, find the minimum velocity of this particle. So here t is equal to 12 given there, and you are going to find out the minimum velocity of that. So this is the region where we are getting the minimum velocity of that particle there. It is a triangle there, and this t is equal to 12 given to us. So the area of this portion is basically equal to half into t is 12 minus 10, that is 2, into the velocity of that particle is v, and that thing is equal to 7.2, because this area is the same as this area, because it has traveled from O to C and then back from C to that position there. So from O to C, it has traveled 7.2 meter. So that thing is equal to 7.2 meter there. So V is basically equal to 7.2 meters per second, but it is in the negative side of that. So velocity should be equal to minus 7.2 meters per second, reverse to that direction there. Then the third part of this, for this part C, then here let's say total time is t there. So the distance traveled from C to this point D is basically equal to half into t minus 10, because total time is 10 there and t is the total time taken for that particle. Speed of that particle is 3, and that thing is equal to the same distance it has traveled, that is equal to 7.2. Then t minus 10 should be equal to 7.2 into 2 over 3. And that thing is equal to 4.8, or t should be equal to 14.8 seconds of that part there. Now, they are asking the average speed of that particle. Since average speed is the total distance traveled divided by the total time taken. Since the total distance traveled is from O to C and then C to O back, because it is having the same distance traveled there. So it is 7.2 plus 7.2 divided by the total time taken there is up till t second, it is 14.8. So it should be equal to 0.9729. So this is the average speed of that particle there. So these are the 4 questions we have solved, and next 3 questions we will solve in the next videos.